would like to introduce myself. My name is Nia Khoirunnisa. This partner
Rizka Alfiana.
We are from Faculty of Science and Technology of Raden Fatah University.
Okay guys, this section we will explain about some properties of liquids and solids, consisting of condensed phases, coefficients of thermal expansion and compressibility, heats of fusion, vaporization, sublimation, vapor pressure, other properties of liquids, review of structural difference between solids, liquids, and gas. Okay, we will be right back. Okay, for the first theory, I will explain about condensed phases. Solids and liquids are referred to collectively as condensed phases. This name emphasizes the high density of the liquid or solid as compared with the low density of gas. This difference in density is one of the most striking differences between gas and solids or liquids. The mass of air in a room of moderate size would not exceed 200 pounds. The mass of liquid required to fill the same room would be some hundreds of tons. Conversely, the volume per mole is very large for gas and very small for liquids and solids. Occupied for a gas at STP 22,400 cm cubic per mole, while the majority of liquids and solids occupy between 10 and 100 cm cubic per mole. Under this condition, the molar volume of a gas is 500 to 1,000 times larger than that of a liquid or solid. If the ratio of the gas volume to liquid volume is 1,000, then the ratio of distance between the molecules in the gas to that between those in the liquid is the cool proof of the volume ratio, where is 10. The molecules of the gas are 10 times farther apart on the average than are those of the liquid. If we measure the forces by the magnitude of the term A per V quadrat in the van der Waals equation, there an increase in volume by a factor of 1,000 in going from liquid to gas decrease the term by a factor of 10. Conversely, in the liquid, the effect of the van der Waals force is 1,000,000 times larger than it is in the gas. In gas, the volume occupied by the molecules is small compared with the total volume, and the effects of the intermolecular forces is very small. In the first approximation, these effects are ignored and any gas is described by the ideal gas law, which is strictly correct only at P equals 0. This condition implies an infinite separation of the molecules. The intermolecular forces would be exactly 0, and the molecular volume would be completely negligible. Next, coefficients of thermal expansion and compressibility. The dependence of the volume of a solid or liquid on temperature at constant pressure can be expressed by the equation V equals V0 1 per alpha T, where T is the Celsius temperature. V0 is the volume of the solid or liquid at 0 Celsius, and alpha is the coefficient of thermal expansion. Equation from pure theory is formally the same as this theory, which relates the volume of a gas to the temperature. The important difference between the two equations is the volume of alpha is approximately the same for all gas, while each liquid or solid has its own particular value of alpha. If the data are to be represented with precision over a wide range of temperature, it's necessary to use an equation with higher powers of T. The formula is V equal V0 1 per AT per BT quadrat, where A and B are constant. For gas and solids, alpha is always positive, while for liquids, alpha is usually positive. There are a few liquids for which alpha is negative over a small range of temperature. For example, between 0 and 4 Celsius, water has a negative value of alpha. In the small temperature interval, the specific volume of water decreases as the temperature increases. If a gas were subject to the same change in pressure, the volume would be half, because moderate change in pressure produce only very tiny change in the volume of liquids and solids. It is often convenient to consider them to be incompressible, where K equals 0 in the past approximation. The coefficients alpha and K are usually given more general definitions than are implied. The general definitions are have the formula is alpha equal 1 per V derivative V per derivative T pressure, or K equal minus 1 per V derivative V per derivative pressure times temperature. If the temperature increment is small, general definition of alpha yields the result and have the formula dV per V equal alpha dt. Key vaporization is equal to A per B. Okay, the next story from Nia Khoirunnisa. Next, heats of fusion, vaporization, and sublimation. The absorption or release of heat without any accompanying temperature change is characteristic of a change in the state of aggregation of substance. The quantity of heat absorbed in the transformation of solid to liquid is heat of fusion. The quantity of heat absorbed in the transformation of liquid vapor is the heat of vaporization. The direct transformation of a solid to vapor is called sublimation. The quantity of heat absorbed is the heat of sublimation, which is equal to the sum of the heats of fusion and vaporization. In obvious But important fact about condensed phases is that the intermolecular force hold the molecular together. The vaporization of a liquid requires the molecules to be pulled apart against the intermolecular forces. The energy required the molecules is measured quantitatively by the head of vaporization. Similarly, energy is required to pull the molecules out of the order arrangement in the cranial to the disorder arrangement, usually at a slightly larger distance of separation. Existing in the liquid, this energy is measured by the head of fusion. Liquids composed of molecules that have comparatively strong forces acting between them have high heads of vaporization, while those composed of weakly interacting molecules have low heads of vaporization. The van der Waals alpha is a measure of the strength of the attractive forces. I accept the heads of vaporization of substance to fall in the same order or the value of alpha. This is in fact correct. It can be shown that for a van der Waals fluid the head of vaporization per mole and
Vapor pressure is the pressure produced by steam at a certain temperature, thermodynamical imbalance, which the condensation piece in a collision system. The vapor pressure of the solution is lower than the vapor pressure of pure solvents because the pressure of solution causes a decrease in vapor pressure. The vapor pressure of solution can be calculated by a relation law, which states the each component in a solution carries the same pressure as the mole fraction of the vapor pressure of a first solvent component. But before determining what formula to use, first determining the type of solution because the factor of Van Hoff causes differences in the calculation formula. This is a formula exit basic and style electrolyte solution. Organic compound equal non-electrolyte solution. The formula used to determine the vapor pressure of the solution is electrolyte solution Liquid or incompressible fluid that adjust to the shape of the container but maintain a element constant volume independent of pressure. As such, it is one of the four basic forms of matter. The other are solid, gas, and plasma, and is the only state which a definite volume but has no fixed volume. Liquids consist of particles of matter with subtle vibration such as atoms, which are held together by intermolecular forces. Water by far is the most common liquid on Earth. Like gas, liquid can flow form like a container. Most liquids cannot be obtained. All the density of a liquid is usually close to solid and is much higher than the of gas. Therefore, liquid and solid are both called condensed objects. On the other hand, because liquid and gas share the ability to flow, they are called fluid. Although water is abound on each, this material form is actually the less common in the known universe because the presence of liquid requires a relatively lower temperature pressure range. The best known matter in the universe exists in the form of gas, with touch of the tunable solid matter. Extensive forms are definite forms taken by definition of matter. Historical, this distinction was made based on qualitative difference in the nature of bulk. In a liquid state, the substance retains its volume but adjusts to the shape of the container, and whereas the gas expands to occupy whatever volume is available. This diagram shows the nomenclature for different phase transition: gas, period, plasma, chair. The difference between the present state of matter is based on difference in intermolecular relations. In a state of solid, intermolecular forces keep molecules in a fixed spatial relationship. In liquid, intermolecular or gas keep molecules close together, but there is no fixed spatial relationship. In a gas state, the molecules are more sparse and the relative intermolecular interchange do not affect their motion. Plasma is a high ionic gas, which occurs at high temperature. The intermolecular forces created by the after the relationship of ion give this state difference properties so that the plasma is derived as the fourth manifestation of matter. They are not composite of molecules and are governed by other forces, can also be considered as different material forms: formation, condensed, and quark-gluon plasma. For example, although solid, liquids, and gases are the most component forms of matter on Earth, most baryon matter in the universe is in the form of hot plasma, but as a rare interstellar medium and as a dense star. Substances can also be defined using the concepts of phase transitions. A phase transition signifies a change in structure and can be recognized from a direction change in these properties. Using this definition, the, the different states of matter are each thermodynamic state that is distinct from other state by a phase transition. Water can be said to have several different solid forms. The emergence of subconductivity is associated with a phase transition, so there is a surproductive state, like we see the state of liquid and for magnetic crystals is characterized by phase transitions and has different properties.
Everybody, if there are any more words for our presentation, we say sorry about that. Thank you for your attention and thank you for watching. Don't forget for like, comment, and subscribe. Assalamualaikum warahmatullahi wabarakatuh. Bye bye.
Oh, he's there in the dark, stare.